Okay, second day of the advent of code. Hello again. Yep, let's do it. So, one thing that I noticed is that there's a bunch of new Zig streamers who are flexing with their hiding window managers and all their complex setups and everything else. And so I got kind of envious and I tried to make my own. It's not as fancy as what other people have, but I try to go in that direction. So here's the development laptop. Here's the advent of code. So I'll show you the development setup after I read the text. So let's see. Password philosophy. Your flight departs in a few days from the coastal airport. The easiest way down to the coast from here is via toboggan. Toboggan. What's a toboggan? The simple sled traditionally used by children. It's also a traditional form of transport used in the Innu and Cree of northern Canada. Oh, I see. Yeah, okay. The shopkeeper at the North Pole toboggan rental shop is having a bad day. Something's wrong with our computers. We can't log in. You ask if you can take a look. Their password database seems to be a little corrupted. Some of the passwords wouldn't have been allowed. By the official toboggan corporate policy that was in effect when they were chosen. To try to debug the problem, they have created a list, your puzzle input, of passwords according to the corrupted database, and the corporate policy when that password was set. So, for example, suppose you have the following list. Blah. Each line gives the password policy. I'm guessing it's this. And then the password. The password policy indicates the lowest and highest number of times a given letter must appear for the password to be valid. For example, 1-3 means that the password must contain, 1-3A means that the password must contain A at least one time, up to 3, I guess. At least one time and at most 3 times, yeah. In the above example, 2 passwords are valid, the middle password is not, it contains no instances of B, but it needs at least 1, yeah. The first and third passwords are valid. They contain 1A or 9C. Yeah, both within the limits of their respective policies. So this is to say that both extremes are included. How many passwords are valid according to their policies? Let's get the puzzle input. Oh, okay. So I have to admit, I'm kind of tempted to cheat again using multi-line editing in the editor, but I think it's time we start getting used to parsing files, because I suspect that as we move forward, parsing is going to become something that we'll have to do anyway. So let's try to move in that direction. So, here's my setup. So I have Twitch chat in IRSSI, and I have also my editor. So that I'm going to show now. So what do we want to do? I think we want to do embed file, I guess, with the text, but now we do have to put the text somewhere. So let's go in, actually, you know what? Just open the editor. Micro. Let's hope I remember how to use it, but it shouldn't be a problem. So we open, actually, no, I don't know if it's a command. Control O. Open what? Source. I want to open day2.txt, I guess. Let's do that for the input. So we paste the input and we save it. Then we open day2.zig. Now we have day2.zig. We don't have yeah, we do have syntax highlighting and everything, so it's set up for Zig. So where do we start? I guess we want to start by loading the file, loading the input. So const input equals embed file. say 02.txt. And to check that it works, std debug print lines. Hey Soapstone, thank you for the subscription. Which made me do this to get emote rewards. Yeah, I'm sorry. Thank you, especially for subbing with Rhyme. I'll show you a secret, and thank you, Belgian, for the follow. I'll show you a secret. So there's something hidden behind my camera that you can only see while scrolling. Wire Prime subs. That's what's always behind the camera. Now you know. So lines, whatever. And then, well, you know what? To know lines, I would need to parse it. Let's just say how many characters are in there. Easier. Input dot length. Okay. Save. And then sig field day 2. Day 02. Chars 20,000. Cool. So we know we are embedding the file properly. Next, I guess, is we have to do the actual parsing. So how do I open a new tab? Control T, I think. Yes. And then we open source day2.txt. And so we now have stuff here that we can see. So we can double check that the syntax matches what we expect. Okay, so we want to do stuff by line. We want to split on a space, on a dash also, a colon too. So yeah, let's get to work. One thing that I think I would like to do starting is, again, this is just, I guess, personal preference. You can probably make do in other ways. Let me think. Re-split them all up and then count afterwards. We could do that too. Now let's do everything in line, whatever. Okay, so what should we use here? Tokenize this file. I think we have tokenize in the standard library. I don't know. Does it? We can use the standard library. Yes. So that would be a possibility. I don't remember how tokenize. What's the signature of tokenize? I mean, I don't expect it to be anything surprising, but double check. Google, provide me with something good. Of course, no. Google doesn't want to provide me with something good. That's fine. So let's go find the standard library. Deep standard. I think it's in mem, but we should start with the file. See if it's implemented here or somewhere else. Is it somewhere else? No, it's probably in here. So search tokenize. There we go, tokenize. So you give it a buffer, you give it a delimiter, and it gives you a iterator where you can do, I guess, next on it. Okay. So we can have a tokenizer that tokenizes on new lines. And then for each line token, we tokenize on... We probably don't want to tokenize anymore, I guess, because since we have multiple delimiters and we want to do more structured stuff, we probably want to do stuff more manually, maybe? I'm not sure. Let's start writing it and then we'll see. So we were saying mem.tokenize gives you an iterator. Okay. Var it equals std.mem.tokenize. Then what? The input. Wait, is input an array or is input already a pointer? I'm not sure what embed file gives you. I know that the intern strings are already pointers, so I'm assuming this is already going to be a pointer. We'll see. So we need to give it that. Then the limiter bytes. Limiter bytes, I guess, is just a new line. Oh, but it has to be sliced, so we can do this. And of course I have code doubling, that's annoying. Pretty sure embed file returns values as a pointer. Thank you. Okay, so we have our iterator. I guess the way we do this is while it.next is producing. So you could see here that it.next here produces an optional that here the test is unpacking. Well, it's expecting to be there. Oh, there's also split. Returns an iterator that iterates over slices of buffer that are separated by bytes of delimiters. So what's the difference? Then I'm missing some details in the difference, I guess. Tokenize will skip many delimiters in a row. I see. I see. I see. I think in our case it doesn't matter much. I think this is what we can assume that it's a well-formed input. I think. So this gives us a line if it's there. So we are using this capture in the while to capture the optional value. And as long as there are lines, what do we do with the line? So we have a line. Let's double check the structure. We want to parse a number, then a dash, then a number again. ABB will give A pipe B will give A B with tokenize IC split will give you other stuff, but I think this is not a problem here. Like this output looks so clean. I don't think we should worry about differences, at least for now. I don't know. Maybe we'll have to worry in part 2. We'll see. Okay, so we want to parse a number. I know there is parse int in the standard library, but the problem with parse int, we can't just immediately use parse int, and I'll go find it. I think it's in here. It's an FMT parse int. There we go, parse int. The problem with parse int is that you can't tell to parse int parse a number when you find a character that you don't like, then that's the end of the number. You have to do that yourself first. You have to be precise with parsing. So I guess that what we can do is like pretty easily const dash pause. The dash position is can I do that directly like this? I have to do, I think, var I equals var I of type usize equals 0. Then dash pose is while line at position I is different than the dash. We do I. Let me think. So what I'm trying to do is a while loop that basically is doing a search for this. So we keep searching. We even need a condition. This could even be just a while true plus. Well, I guess so. I shouldn't put the condition here, I think, because then otherwise I can't break with anything. So while I is lower than line.len, every iteration we do I plus equals 1. And then in here what we do, if line position I equals the dash, we break. Well, actually, we don't even have to break with anything, but whatever. So we break with I. and that's it. Else unreachable. Well, actually, you know what? Let's do else panic. Panic. So dash. So this beautiful one-liner works. Maybe I should make it a multi-line thing. And it doesn't have even to be an expression, to be fair. Because if it's yeah, it doesn't have to be an expression. So let me put some a block that makes everything a bit less awkward, I guess. And we can do the same here too. Put some graphs. So parentheses. Yeah. Okay. Is this gonna work? No. What am I missing? I think this needs. Okay, there we go. So now it looks less weird. We're using the while to perform a search. So we find the position of the dash. Else is in the wrong place. It needs to be. Oh, you're right. Else is in the wrong place. Else needs to be. You are perfectly right. Else is an else of the while. So so we need a thing here, and I think this has to go then. Yeah. Okay. Now it's correct. Good point. Thank you, Soapstone. Okay. So we find the dash. We know where the dash is. And I think we could. This could be abstracted as a function because we'll have to do it again, I guess. But whatever. For now, let's do it like this. So we have the dash, and so we can now parse a number. So const the minimum amount of characters is going to be then try std.mmt.parseInt, and let's see the signature of parseInt. We want to say number type that we are trying to parse. In our case, size is fine, I guess. The buffer itself, which is going to be line from 0 until dash pause. Oh, it's kind of annoying because it's a situation where really using I would work anyway. I like how you can use while to express a search, but in this case, the I ends up being precisely the same thing. But whatever, let's be explicit. So this is the buffer that we want to try to parse, and then I think we have the base, right? Yeah, the radix. Okay, so base that. Now, have mean. Next is to find max, and it's the same thing, except the character changes. So let's do a function. Function find in buff. It's a slice of const u8. Needle is a character AU8, and it returns AU size. Yes. Reasonable interface, maybe not the best. Also, why is this thing inside here? This should be. Oh no, what happened? Enable dictation? No, Mac, I don't want dictation. Thank you very much. Interesting. Why do I also have that in my buffer? Okay, so I think we want to basically move everything here inside here. Okay, so we have find, and instead of breaking, just returns, I guess. Return I. We don't need to use the while as an assignment. What? Wait a second. What happened here? Oh, I cut also the outer line thing. Okay. Okay. I was getting confused by why is my pace so weird? Oh, because it's not like Sublime. Okay. Good to know. So yeah. Go here, save, so I can get some formatting. This one doesn't require this anymore. Can I have some formatting now? No. Why? Expected semicolon. You're right. Okay, we just return I, and that's it. Character is our needle. And this seems fine. So now for each line, we want to find the mean, which is going to be well, give it a dash pause. Const dash pause equals find line character. And so we have the dash pause. Okay, and we find the minimum like this. Then const space pause, and I think we don't have a space, right? Yes, we have a space right after the second number. So space pause is find. One thing that we should do is consume the line. So I think we should do. Should we wait? Whatever. Yeah. So we want to search from line starting from dash pause, I guess, moving forward. And the needle is, in this case, a space. So now we have const max is try std fmt parse int usize line starting from dash position +1, because we don't want the dash itself. And actually, same is true here too. So dash position +1 until base. Okay, and now we have min and max. Next we need to find the letter, which is going to be the next one. So const char is line starting line at position space pause. So space position, yeah, gives us the space. So we want to do +1. 1. This is the character. And next, what do we need to do? Thank you for the blue screen, Souston. What letter is this? Vim? No, it's micro. It's like a dumbed down version of Vim, sane version of Vim. It's a terminal editor written in Go. None of the madness of Vim when it comes to thousands of plugins, configuration stuff, super complicated. It's like simple configuration, simple key binding, simple operation. It doesn't have Vim input mode though. I think they're working on it. If you read the README, they say they want to add it next. So maybe you might not like it if you're used to those key binds. But what I appreciate the most, it's not really even the interface. It's just that it has reasonable defaults out of the box, and you don't have to write Vim script stuff to make it reasonably useful. So we have the character. Now we what else do we need? We have a colon and a space, which kind of makes me want to skip 2 bytes. And I think that's what I'm gonna do. And then we have everything until the end of the list. Now, this is assuming input is always clean and nice. Not the most robust way of parsing stuff, but hey, it's probably good enough for this challenge. So we have the char. Now we have the password. Const password is line starting at, so space position +1 gave us the character. Space position +2 plus 3 plus 4 give us the first letter. This one until the end. So now we have the password. And at this point, we need just to check. You know what? We can even, well, let's leave some new lines in there. It's kind of cool. So what we do here is check conditions. And so check conditions, we need to do if so we need to check that the character is within the limits. So we need to count the instances of that character and then decide if it's within limits. So const char counts equals we do this way. Let's see. So we can make a block and we can say var counter equals 0. Counter needs to be usize. Oops, and of my R. So what counter usize? Do we do for password ch if ch equals r counter plus equals 1, and at the end we break the block with counter. And this needs a semicolon, yes. So we keep increasing the counter, and then we break from this block with the final char counts. So char counts, and then if char counts is greater or equal the mean, and wait, I'm having a brain fart. Keyword end is allowed, right? It's not just end. I think yes. And char counts is lower or equal to max. Then we need a final counter var good passwords equals size equals 0. Good passwords plus equals 1. And at the end, once everything is done, std.print good passwords equals something, new line. And that's it. Any error? Doesn't seem so. Is this gonna compile first try? Time to see. Dig, build, laser2. Okay. Invalid character tab. Oh no, wait. Am I not running this through... Am I not running this through zigfmt? I'm pretty sure I am. Oh no, there is an error. Here's why. Okay. That's why it's not expected. Found. Oh yeah. Right. Did I do it also above? No. Okay. I'm not used to micro. I should have noticed that the bar was a little bit shifted, which means that there was an error somewhere, and I didn't notice the error. Okay. No. Save b zig build day 02. Okay, expected type const-u8 found u8. Oh yeah, that's a good point. I'm missing the dot dot. Okay, line 16. So yep, start from here until the end. That's one. We have like a history. Yes. So next problem. Expected arguments found 2 in parse int. Yes, okay. I forgot the base, I guess, in the second parse int. Of course. And then use on the car identifier line day02 line 43. Because it's not line, but it's buff. I'm kind of tempted to just rename these to line. No. Buff. Buff. Okay. Oh, we panicked. Index out of bounds. Interesting. Okay, so index out of bound, line 27. Index out of bounds, line 27. What? Excuse me? No, wait, okay. Why is this? Oh my god, please don't ask again about stupid dictation. So, what? How can counter plus equals 1 return index out of bounds? And we panic during a panic. I think there's something fishy going on. So is this a block thing that is causing problems? I don't see how this could cause a out of bound or this cause a out of bound. These things should not be possible. So, okay, let's start debugging this by, let's do this thing then. Let's short circuit a little bit and let's see that if we are parsing everything correctly. So std.debug.print mean, then you know what, let's close this square brackets, mean, max, char, new line, mean, max, char, and then here we continue. We might get a problem because part of everything is, yeah, it's unreachable code. Okay, so we need to comment this stuff, I guess. Control this maybe. Oh yes, save. Index out of bounds. Interesting. Index out of bounds where when we're trying to find min. Okay, interesting. So maybe it's fine that is wrong. Let me think. Increase I by 1. If we find the needle, then that's the position of the needle. And so we use it as the upper bound. That should be fine. Why is it not finding my dashes? Are there really malformed lines somewhere? Could be that, oh, there is a 100th line that I think I should delete. Could that be it? No, but the problem happens at the first line already. This is interesting. So the problem happens at the first line. And it happens immediately when you try to do parse int. Dash pause. Oh, wait. I know one thing that is happening that is wrong. And now that I think about it, if I'm passing to find sliced, like reduced versions of the of the original slice, I can't then use the returned index because the returned index is relative to my slicing. That's a problem. I can't use that as the second end. So to do that, I need to make I guess partial slices as I move forward. That's one way of doing it, I guess. But let's do that. So const from, I guess we can call it from line after dash is this. So we can call it line after dash. And now we can do line after dash starting from 0 until space pause. Okay. And that that does the second half. And then we need to make another line after something. So const line after line after max, I guess. No, that would be line after space, which is line after dash starting from space position +1, I guess. Oh, but let me think about this. Space pause. Yeah, I'm kind of thinking that maybe I should not have. My abstraction is causing me problems. That's funny. Just trying to factor this thing out in a function is causing me problem with relative indices. So funny. Okay, so line after space is line after dash plus the offset where the space is +1. And now here we can do char is the first character. It's line after space immediately. And then password is line after space. No, wait. Character is not immediately after the space. The character, oh yeah, no, it is. Yeah, that's immediately after the space. And then 1, 2. And then we need to do plus, starting from the third index, I guess. 0, 1, 2, 3. Yes. That's the password. Okay, so now I fixed some problems with my indexing. Let's see how we are faring now. Access or array of type U8. Lines after space. Oh yeah. Dot. Okay, so now we are actually printing everything in a way that makes sense, I guess. Yeah. Character, I'm not printing character in the right way. It's printing the number. Let's print a nice looking character and then we can say that our test is successful. Oops. Yep. Okay. So let's comment this. Comment this. Let's remove comments here. Save. Nice. Let's see if we encounter any problem. Oh, good passwords. 591. Okay, so I think we might have solved all the problems that we had. It's just stupid relative numbering and me making a very dumb mistake. 591. Is it? Yeah, that's the right answer. Let's go. Part 2. Part 2. While it appears you validated the passwords correctly, they don't seem to be what the official Toboggan corporate authentication system is expecting. The shopkeeper suddenly realizes that he just accidentally explained the password policy rules from his old job at the sled rental place down the street. The official Toboggan corporate policy actually works a little differently. Each policy actually describes two positions in the password, where one means the first character and two means the second character, and so on. Be careful. Toboggan corporate policies have no concept of index 0. Okay. Exactly one of these positions must contain the given letter. Oh, that's funny. Okay. Other occurrences of the letter are irrelevant for the purposes of policy enforcement. Okay, so we want in position 1 there has to be an A. Wait, decide the position of the password where 1 means the first character and 2 means the second character, and so on. So either the example from above, this is valid because one of the two positions contains letter A. This is invalid because neither does. This is invalid because both positions contain the same letter. So it's like only one of the two has to contain the letter. How many passwords are valid according to this new policy? Okay. Well, you know what? Let's call this. Let's copy this. Call it part 1. Function main void. Yes. Try part 2. So part 2. How do we do this? We want to do everything as before. Maybe we should name min and max as like A and B, or like pos 1, pos 2, position 1 and position 2. Or actually, even better, check 1 and check 2. These are the two checks. Everything parses as before. The condition is slightly different. The condition is that instead of doing counts here, we don't need to do counts anymore, I guess. All we need to do is say, oh, do we have a XOR in, I don't think we have XOR, so we need to make the two pools, I guess, const. Check 1 positive equals password position check 1 plus 1 equals r. Oops, okay, I think I pasted the wrong clipboard. Copy, paste. So position check 2 plus 1 is where we do check 2, and then and then we say this only if check 1 is positive, and let's start adding parentheses. They're going to be useful. So check 1 is positive and check 2 and check 2 is not positive, then we could. Or check 1 is not positive and check 2 is positive. In these two cases, good passwords plus equals 1. Let's build. Index out of bounds. Oof, again. Oh, because it started here. I think these. Okay, I'm getting weird. I'm getting weird traces and panics and stuff because I'm on the new architecture. But yeah, so index out of bounds. Why am I getting an index out of bounds based on the positions check 1 and check 2? Let me think. Could be that we have some checks that are out of bounds. You know, I would like for this to print what the password and the check. Let's see, can we copy this? Yeah, I think I'm gonna copy this. Oh, this is not pasting everything in a new line automatically. That's disappointing. Max char. Okay, so and I think I want password then. So new line, password, and then new line, new line. Okay, so let's see why we're getting out of bounds. Error used on the client identifier mean. Oh, right, these are being renamed. 1, 2. Oh my god, I'm so dumb. C1, C2. Okay, let's see. MPCH. Index out of bounds. Why? Oh, right, because these are indexes, I guess. No. 4, 5, and then that. Am I parsing this wrongly? So position 1 into. Oh, you know what? I'm an idiot. I'm a complete idiot. Okay, I found what the error is. Why am I doing +1? This has to be -1. I don't know. I don't know what's up. There we go. Okay, there's a bunch of garbage being printed, but we have 335 good passwords. It's, I don't know, it's like you don't think too deeply, and then the, oh, be careful, there's starts by 1. Okay, so I need to add 1. No, the opposite. Yeah, right answer, gold star, yay. Sorry, Omniboy, I'm not checking chat much while trying to solve this. I just want to get through it as fast as I can, which is still gonna be fairly slow. Yeah, it took me an hour to do everything, but hey. So that's pretty much it for the advent of code. I'm sorry, Omniboy. I'll be doing normal streams tomorrow in the other days. For now, I'm just doing the summer of code, and as soon as I'm done, I'm gonna shut it off. And I just want to make like fairly well packaged videos for YouTube, I guess, more or less. So, oh, GW1 has how we parse them. How I parsed it. Let's see. Can I open this link? Is there a way for me to open this link? Oh, yes. All right, you can tokenize on this one too. Nice. You're right. Wait a second. Wait a second. Num1 next. Oh, because it doesn't have tokenize doesn't have to encounter all of them. Oh, right. So my assumption was, and I didn't think about it, that if I pass multiple things to tokenize, it would have to find all of them to trigger. Well, no, this is like is parsing in a, I don't know what the right word is, the opportunistic way. Because if it finds only the dash, then it will stop anyway and give you this. Then it finds a space. So it's like any of those. It's fine as long as it finds any of those. That's interesting. That's nicer. That works too, I guess. Still, yeah, less lines, less stupidity with partial indexes, I guess. That's good to know. Pretty cool. I mean, as long as these don't show up in the password itself. I see. Well, thank you for sharing. That was funny. So yeah, this is done too. Before I leave, I prepared one thing. Let's see if it's set up. So I guess thank you everyone for watching.